Hello everyone, my name is Matthew Kilgore.
And I'm Britta Kilgore, and this is Arbitrary Code Execution in Emacs and Ctags, demonstrating CVE 2022-45939. This talk is the final hack for Lawfare's cybersecurity course. But it's also a good demonstration of how to exploit a vulnerability on which there is very little literature. There'll be a lot of explanation and background. Our apologies to Scott and Sean. In the course, we covered a number of hacking vectors: dictionary attacks, rainbow tables, man-in-the-middle attacks, SQL injection, website spoofing, more about Metasploit than can fit here, crypto drainers, and more. Let's ignore all of that.
We'll be focusing on the vulnerability designated CVE 2022-35939. Here is the specific summary of the CVE. Put simply, this vulnerability allows a utility bundled with Emacs called Ctags to arbitrarily execute code if supplied with a specially crafted file name. This is a new vulnerability. It was discovered a bit over a month ago and is still unpatched in the currently available versions of Emacs. The severity score ranges from a 0 on cvedetails.org to a 7.8 on the NIST database.
When using the Linux shell, what you type isn't always interpreted literally. Among others, a blank space terminates an argument. $sign begins a number of special operations, and backslash is an escape character. But you can still also use these characters regularly via various quoting mechanisms. We only need to remember 2 points for our CVE. $sign parentheses spawns a subshell which evaluates the inner expression. Single quotes override all special interpretation in favor of the literal values of the characters wrapped in the quotes. However, a single quote immediately delimits this effect and cannot appear within the literal region.
Here is a quick demonstration. We create one file named file1 simply by touching that name. Then we create a file called file2 by echoing out the 2 in a subshell. Finally, we take that same pattern for file2, but place the entire thing in single quotes, canceling any special execution of a subshell. The result is the following 3 file names.
The single quotes aren't a part of the third file's name. That's just how the shell that we're using renders it. According to the CVE description, Emacs/Ctags somehow allows metacharacters in file names to be interpreted non-literally.
Here is the entry for the specific CVE on cvedetails.org. At the very bottom, you may notice that there is a link to a Git entry. This is in fact the commit that patches the vulnerability. Searching through that commit for the call to system, we find that this is the region which introduces the vulnerability.
The if update means that this code path is only invoked when Ctags is called with the -u option. The string of STP copy calls is building up a command to be passed to the shell via the system call. According to the CVE description, this last part is where the vulnerability lies. We need to know what exactly the command variable contains. We have two options. We can take the time to carefully read the sequence of calls that build command. It's just string concatenation. The xmalloc gets us 95% of the way there anyway. Or we can be lazy and build our own copy of Ctags with a printf added.
Well, we opted to be lazy. Here is a screenshot of our custom build of Ctags running on some test files that I used. As you can see, the command invokes grep on a string delimited by single quotes, including the file names. As such, we can escape this string and re-enable arbitrary code execution if our file name includes a single quote followed by a shell sub-expression followed by another single quote. Right, now let's actually demonstrate our vulnerability. The first thing we're going to do is we're going to create our malicious script. That horrifying tangle of double quotes, single quotes, and backslashes is exactly what we mean when we talk about complicated quoting mechanisms. However, let's quickly look at what our script does. Yeah, all it does is create a silly file. Now, let's create some source files. And another one. And now let's create our malicious file name. Now, let's run Ctags. Now, as you can see, that fails because we've never actually run Ctags before, and we're telling it to update. But regardless, let us look at the output. And as you can see, there is our silly file name on the second row. As you can see, it was created after we created the other ones, right when the tags file was created. As such, our script ran.
How dangerous is this vulnerability? It's hard to say. On the one hand, the exploit is somewhat clunky to deploy. The victim has to use Ctags. They have to be running Ctags -u specifically. and they must run said command on a compromised code base. On the other hand, arbitrary code execution. This can't be deployed against the average user, but it could plausibly be used to target, say, developers at a software company.